Think about where our energy comes from. Drilling rigs and smokestacks, windmills and solar panels, maybe even lithium-ion battery packs might come to mind. What we probably don't think about are the farms that make up over 1/3 of Earth's total land area. But it turns out that they can be an energy source as well. Barcelona-based battery company Bioo is generating electricity from soil and creating biological batteries that can power agricultural sensors, eliminating the need for single-use chemical batteries.
So soil is actually, very rich in fuels, and you're just harvesting that fuel in this case.
Bioo is hoping that its biological batteries can help to power the $1.36 billion global sensor market. Stick one of Bioo's reactors in the ground, and so long as the soil is irrigated regularly, the battery will provide an always available source of power to the attached sensor. In turn, these sensors give farmers the information they need to irrigate and fertilize their crops most efficiently.
Farmers around the world are buying more sensors every single year. They're used to measure humidity, temperature, pH, but after all, how do you charge those sensors? Literally an army of workers having to go to the fields and replacing the batteries themselves, which is not really just very expensive, but quite polluting as well.
Bioo is working with large companies like Bayer Crop Science to change this, piloting their sensor tech on farms while also experimenting with using biobatteries to power lighting installations. Eventually, Bioo envisions a future where biology could even help to power our largest cities. Standard batteries rely upon chemical reactions. For example, in a lithium-ion battery, lithium ions move from the negatively charged side of the battery, the anode, to the positively charged side, the cathode. This creates free electrons, which move through a separate wire, carrying an electric current from the anode through the device being powered and to the cathode. But instead of using an element like lithium, Bioo uses organic matter as fuel. Within the soil, microorganisms feed on organic matter, breaking it down in a process that releases hydrogen ions as well as electrons. Inside the Bioo device, there's a wire that transports the free electrons from the anode to the cathode, powering the sensor in the process.
We are producing energy in a constant basis during day and night time. It doesn't matter if it's raining or it's a cloudy day, they will produce energy.
Bioo is not the first to make batteries from organic compounds. Biobatteries using enzymes that break down carbohydrates, fatty acids, and alcohol have been developed in labs for years. Many are introduced to the infamous potato battery demonstration in grade school, which shows how the acids in a potato can be harnessed to power small lights or clocks. There have also been a number of trials focused on producing electricity from the organic matter found in wastewater, and using that to treat the wastewater itself, but the tech has not yet been able to scale. At the University of Utah, Professor Shelley Mentier's research group is working on incorporating sensor tech to gain mass adoption. It all comes down to price and operational efficiency.
At this point, it becomes an issue electrodes with how you're going to wire everything together and just how efficient that you can make those systems.
Much of Bioo's tech is made from graphite, which is abundant and cheap. Less expensive even than the materials used to build solar panels, which can also be used to power single-use chemical batteries may need to be changed multiple times a year. Vidarte says that Bioo sensors can last up to 10 years and cost less than €1 as compared with €4 to €10 for sensors powered by chemical batteries. Many say that's what will truly make the difference.
We have a growing audience that is very, very interested in saying, what can I do, what can my family do, my organization do, to not only be sustainable environmentally, but first and foremost, economically. Everybody says that they want to be helpful to the environment, but I think the biggest driver right now is economics.
Canoe Group is an agricultural organization that brings together different stakeholders interested in regenerative land management and farming practices, and it plans to test Bioo's sensors in its fields later this year.
Collectively, we're in touch with probably about 20 million acres of private lands, and all of them are focused on regenerative agriculture.
Bayer Crop Science also plans to test Bioo's sensors this year, and if it ends up adopting them widely, it could lead to major savings.
Right now they have like 50 million hectares of land using sensors specifically. So they've calculated that by applying these biological reactors for their sensors, they will be saving 1.5 billion euros per year.
Bioo will be running pilots throughout 2021, and next year it hopes to officially go commercial with its sensors. In the meantime, it has a number of other projects in the works, including Bioo panels, which are basically just larger biological batteries that are placed fully beneath the soil and can power single lights or full lighting installations day and night. They work using pretty much the same principles as the Bioo sensor. The constant breakdown of organic matter in the soil means that the panels are constantly providing power, but cannot store energy on their own for later use.
A lot of us now have lighting outside that is using solar. And so rather than having sort of that solar light that is lighting your flower bed, actually using the flower bed to light that light, I think is a perfect example.
Bioo is also working on a number of experimental art installations that showcase the ways in which plants can be used as so-called biological switches, detecting frequency changes that can be transformed into voltage in order to turn on lights or emit sound, as in this piano installation at the Ibiza Biotechnology Botanical Garden.
What we do with them is to actually detect the exact frequency between a human touch and a plant. So actually, if you touch the plant with a metallic bar or with a phone or whatever, it won't get activated. It just gets activated with a human touch.
Vidarte hopes that these installations will help to inspire designers of cities and public spaces to incorporate the natural world into their blueprints.
What we do with biological switches right now is literally a transformation in architecture, in actually creating a city that it's able to literally combine with nature itself.
And the panels, he hopes, will one day help to power these biotech cities of the future.
Even imagine farmers using their own fields, not just to create foods, for example, but actually to nourish not only human beings, but also cities themselves, the energy needs of cities.
But Bioo does expect that it will be able to exponentially increase the energy density of its batteries in the years to come.
In the next 10 years, we're really going to see a great leap. I mean, since we began with Bioo, the energy productions of our batteries have been multiplied 1,000 times. And actually, in the last 5 to 6 months, we've increased our energy outputs by 4 times.
Vidarte says that in the lab, Bioo panels are able to produce about 3.7 watts of power per square foot, about 1/4 that of a solar panel operating at average efficiency. This is impressive given the constraints of using soil as a conductor of electrical current. But there's still no...
Unlike a piece of metal, a microorganism is not conductive. And so, looking at how you can develop strategies to improve the overall conductivity of the cell, how you can improve communication between the microorganism and the electrode, how you can decrease resistance in soil, all of those are sort of engineering feats that need to be handled.
Because of this, Mintier says that sensor tech is a good place to start.
Obviously, powering sensors is something that's a relatively sort of low power application. Transportation and airplanes would be sort of high power needs, and you're not going to make it to that area. Sort of where you are in between is going to kind of depend on how inexpensive they can make the materials associated with the battery.
While Bioo hopes that 2021 will be the year that its batteries are proven at scale, it has been able to generate lots of buzz in the meantime, raising a total of 3.5 million euros in funding, approximately $4.3 million. The European Union overall has been its biggest supporter.
The European Union has actually invested 2.5 million euros in the company, way more than double that what we got from the private funding.
Supporters are banking on sustainable and regenerative agricultural practices continuing to gain traction. So far, Bennett says he's found a willing audience of farmers to test Bioo's tech.
Those that are already in the realm of taking on regenerative agriculture, those are the ones that we're focused on, and that's in the millions. We don't have a problem with finding an audience.
As Bioo grows, it doesn't plan to manufacture sensors and panels itself. Instead, it wants to license its biobattery tech to agricultural companies that already make sensors and have the manufacturing and logistics know-how to drive mass market adoption.
We're going to go straight forward to companies that want to actually use this technology and that already have a network of clients, and they already have products that are applicable with this technology.
With it from, Bennett sees the market opportunity for a product like Bioo sensors continuing to expand.
The audience is going to say, so tell me, how are you powering your agriculture? How are you powering these food sources? What's in the soil? We didn't ask that even 10 years ago. We didn't ask that really even 5 years ago. We're starting to ask it now.